Hello guys, welcome back to MedZone African Motives, still on our power machines and 5 revisions, working on the steam generation calculations that we involve when we are dealing with steam. In this case, it's very, very important to know your formulas and also to revise more questions. As you can see, these questions, they do repeat. You check August 2021 question paper, you'll see a similar question to this one that we are going to revise. This one is from the question paper of November 2022 exam, which is just similar to August 2021 exams also. So we're not going to waste much time. Let's quickly rush through the question and see what we are given. On question number 3, we're given 2,3 kgs, take note, of steam at a pressure of 1,200 kilopascal and temperature expands until the pressure is. So these are inlet values at the beginning of this part. We are given the mass of steam being 2,3 kilograms. So we've got the mass of steam here being 2,3 kilograms, and also the pressure at the inlet at the beginning, 1,200, temperature of 230 in this case. All right, so take note here, we're talking about the steam at this pressure, the steam at this pressure. All right, so meaning to say here we are considering the pressure that is affecting our steam of 1,200 kilopascal, and also the temperature there, which is at 230. So that was at 230 degrees Celsius in this case. All right, so this is our temperature. Shall see what's happening here. The dryness fraction of steam after expansion is 0.8. The specific heat capacity of the superheated steam is. All right, so take note, so we left, it expands until the pressure is. So from this pressure to this, so meaning to say here, they are talking about a condition whereby the steam is from the superheat, like we are having. Remember, we have got a condition where we can start with water to steam. So here it's a conversion from the steam back to water. That is what is happening here. So if we check, this pressure is considering for the superheater in this case. So this temperature is for the superheater, this one. All right, so now if it expands to a lower, as you can see, it's a lower pressure that we have. So this is our P2. We're gonna just consider this as a P2 of 500 kilopascal in this case, when we are now talking about the steam, which is the wet steam in this case. So here we are now referring to wet steam. All right, so when the steam is wet, that is where we are given the dryness fraction of steam after expansion is 0.8. So we've got the dryness fraction there of 0.8, and also given the specific heat capacity, which is 2 kilojoule per kg Kelvin. All right, so this is given per kg Kelvin, supposed to be per kg degrees Celsius, since we are dealing with our temperature in degrees Celsius in this case. So this is specific heat capacity for the superheated steam, that is 2 kilojoule per kg Kelvin in this case, but we are supposed to have this per kg degrees Celsius, since our temperature that we are working with is in degree Celsius. All right, so that is what we're gonna have here, and the index N is 1,3. So we are given also the index of N, which is 1,3. So we've got our index of 1,3. And that's it. That's what we are given, all the information about the steam. So the first question was to calculate the specific enthalpy of superheated steam in kilojoule per kg, per kg. We are given a mass of 2,3 kgs in this case. If we are to use that, they are not going to write per kilogram in this case, per kg. They are just going to write the enthalpy, which is in kilojoules. If it is like that, you multiply. If it is in kilojoules, you multiply by the mass. So there we are just taking it per kg of everything. So there's nothing that we are going to consider. In this case, we are not going to consider this mass for a particular part, but If it is a quantity, please take note, if it is a quantity that the answer is needed in kilojoules, you have to multiply by that mass. All right. So there, the enthalpy of superheated steam, all right, this we can, I want this information here. We can simply take this part. If you do not know these formulas, then be geared up to be working with your formula sheet as much as you can. All right, so on your formula sheet here, we've got the formula that we use to calculate the superheated steam, which is given as H is equal to Hg plus Cp times the change in temperature. So I'm going to explain this formula that we are given there. That is for the superheated steam. So if you are to check, we are given our formula. We are supposed to have this formula as H sup in this case is equal to Hg plus Cp into the change in temperature. That is this TSS, which is the temperature that we are given for the superheated, in this case, the initial temperature there, and also minus TS, which is for water. That is the saturated temperature in this case. We need the change in temperature from when it was water to when it was now steam from that part that we are given. So where are we going to have these values? Because there we are given TS, which is this temperature that we have for the steam, that is for the dry steam in this case, I mean for the superheated steam, that is the one that we are given there for the what? The superheated steam. So TS, which is our saturated, is the one that we need, and also we are going to need Hg in this case for the dry steam, in this case, meaning we are going to need the pressure there of 1,200. So at 1,200 kilopascal, we are going to need Hg from there. Also, we are going to need TS, which is our saturated temperature. So let us check from our steam tables in this case. All right, so we're going to need our steam tables in this case at 1,200 on pressure. So we are going to need our pressure. As you can see, our pressure is already in kilopascal. So we are going to go under 1,200, under 1,200. So this is it at 1,200 here. We are going to need the values that are going to correspond across this 1,200, this one. All right, so this is where we are going to take our values from. So there, what are we given? It is the pressure. So we use the pressure. Remember, we need what there? We said we need the temperature, which is TS, our saturated temperature there. TS at 1,200. So at 1,200, TS is this one, which is 188. We also need Hg there. If you check here, we've got Hg down across this column. We are going to need Hg there, which is going to correspond at 2,278 kilojoule per kg. So these are the values that we are going to take. All right. So as we saw, we said we're going to need Hg. It was 2,782 kilojoule per kg. And the TS, which is our saturated temperature, there was 188,0, which is in degrees Celsius. So that's 188. So these are the values that we are going to need at this pressure. We are going to consider the pressure there, meaning to say we are going to have our Hg, which is 2,782 plus the specific heat capacity there for the superheated, which is going to be 2 kilojoules into TS, which is TSF for the superheated is 230, all right, minus TS, the saturated one, which is 188 in this case. All right, so that was the whole idea of our question here. We are going to obtain this per kg. So that is going to be 2,866 kilojoule per watt per kg. If we are to use the mass that we are given there, it must be given as a question whereby they are saying in kilojoules. If they say in kilojoules without per kg, there you are going to multiply by the what? By the mass for 3 kgs. For 2,3 kgs, we're going to multiply for 2,3. So meaning to say if it was for 2,3 kgs now, and if you multiply this, it's gonna be 2866. So you're gonna have 2866 times 2,3. So the kilojoule, remember this is kilojoule per kg and this is a kg. So this will cancel. We remain with our answer in kilojoules. So that will be 6,591,8, which will be in kilojoules. So there they're saying per kg, so we're not going to use that mass, okay, because it's already in per kilogram. All right, so the volume of superheated steam in cubic meter again per kg. So we need the volume of the superheated steam. So where are we going to have the volume of the superheated steam with the information that we are given in this case? All right, so for the volume again, from our formula sheet, we are going to consider the volume for the superheated. In this case, we've got this formula whereby we have got everything. We have got this H soup at the pressure, which is at the pressure P1 as we are given. So this is the formula for the volume for the superheated steam, which is V soup in this case. So that is V soup is equal to, or just write VSU, which is fine. All right, so this is equal to, from our formula, it was N, or N minus 1 over N into H soup minus 1941 over the pressure in this case. So this is the pressure that is affecting our superheated steam, which is the pressure. In this case, we're talking about P1. So that means there we're going to have our volume in cubic meters per what? Per kilogram, if we are to calculate. All right, so that's it. Our N is 1,3. So let's see our information. Everything is there. So we are going to have, we say this is 1,3. So it's going to be 1,3 minus 1 over 1,3 into H soup. We calculated this before. We got 2866 minus 1941 over the pressure. In this case, our pressure is at 1,200 for the superheated. In this case, the one that we used here, which is at 1,200. All right, so that's it. We are going to obtain this volume in cubic meters per kg. So this was going to be 0, so that's 0,1778, which is going to be 78, which is cubic meters per kilogram. If the question was for you to calculate this in cubic meters, then you multiply by the mass that you're given, 2,3 kgs, you obtain the exact volume. But here they need it per kg. All right, so that is how you attempt such typical questions. Then the internal energy of superheated steam in kilojoule per kg, again, the internal energy. So the internal energy in this case is given by U. So if you check on our formula sheet again, the internal energy, we're going to consider this as U1. For the first condition, we're just going to take this as U1, remember at P1. So here we've got our formula for U in this case, which is given U is equivalent to H minus PV. All right, so I'm going to explain this formula. What are they trying to say there? They are saying U is equivalent to H minus PV. So this is the, if you are referring to U1, this is going to be H1, this is going to be P1, this is going to be V1. So since we are talking about the internal energy of the superheated steam, meaning to say this is going to be our H from the superheated steam. This is going to be the pressure from our superheated steam, the volume from the superheated. That is how we are applying this formula. So there, we are going to have our U1 as H1, which is the superheated here, H soup, which is 2,866. So we're going to have 2,866 minus P1, the pressure at the inlet, which is at 1,200. That's our P1 there at 1,200. So we are going to have this as 1,200 times the volume now, which is the volume of the superheated, the one that we calculated. Since we are dealing with the superheated, so we're going to use the volume of the superheated, which is 0,178. All right, so that's it. We are going to obtain our internal energy in this case, which is going to be given as 2,652 4, right? So you're going to obtain 2652.4, which is in kilojoule per watt per kg, right? If it is in kilojoules, therefore you multiply by 2,3 kgs, but there you're just going to take the value as it is because it's needed in what? Kilojoule per kg. Then after that, they want us to calculate the specific enthalpy of, now we are talking about the wet steam. We are back to the wet steam where we are supposed to start from wet steam to dry steam. So now at wet steam, we are talking about at the pressure of what? At the pressure of 500. So these are the conditions that we are now working now for the wet steam. So remember H wet in this case, let us just calculate our values here. So that's 3.4. H wet is also from our dryness fraction. This is the formula that we're going to take for H wet. All right, here on top here, H, which is HF plus XHFG, whereby you're considering the dryness fraction there. So that's the formula that you are going to use for H wet. So meaning to say our H wet is going to be given as HF plus X HFG. So as you can see, there are enthalpies to be calculated because we do not have. So, and if we take a consideration here, our H wet is taken at a pressure P2, which is 500 kilopascal. So meaning to say we are going to calculate our HF and our HFG at 500 kilopascal, meaning to say we are considering our P2 of 500 kilopascal in this case. All right, so that's 500 kilopascal. So what is the value of HF there? What is the value of HFG there at 500 kilopascal from your steam table? All right, so let's get to our steam table at 500. We need pressure there. Pressure must be 500. All right, so if you check on this page, that was the one that was going to correspond to 500. All right, sorry for that. Let's check here at 500. That's at this point. So remember, we are dealing with what? We are dealing with the pressure here at 500. So this is where we are going to consider our values from. We are going to consider from this line here. So remember, we need HF, and this is the column of our HF here. And the corresponding one is for HFG. So these are the ones that we need, HF and HFG along this line. So as you can see along this line, that will be our HF and this will be our HFG. So we're going to take this for HFG, and for HF, we are going to use 640 in this case. All right, so let us put our values. These two values are the ones that we're going to need, HF and HFG. So remember, all right, sorry for that. You're gonna need this here. So remember our HF there, we obtained 640. That was 640 kilojoule per kg. HFG, it was 2,107 kilojoule per kg again. All right, so that's it. Let us substitute our values here. So meaning to say we are going to obtain H wet from there, which is HF at this pressure. That's 640 in this case. So 640 plus the dryness fraction. In this case, if we are to take, we are given the dryness fraction of 0.8. So we are going to take that as 0.8 from the value that we have. That's 0.8 times HFG, which is 2,107. Together we combine. So this is going to give us H wet, which was going to be 2,000. So it was going to be 2,325.6 in kilojoule per watt per kg. Since this is needed in kilojoule per kg, unless if it is needed in what? In kilojoules only, that's where we have to consider. That's where we have to consider the mass that we are given. So that is it for H wet. Let's move on. Then they are saying again the volume of wet steam in cubic meters per kg. If we are dealing with the volume for wet steam, again, all these formulas we are given. All right, so let us, meaning to say we are supposed to work with H wet in this case. So this is 3.5. So from our formula sheet, we are going to see this formula for the volume of wet steam. All right, this is taken from this formula here. Vm here, this one, x is equal to Vm over Vg. So from this is same as over 1. So you can cross multiply, meaning to say, if you multiply 1 times Vm, we are going to have Vm is equal to x times Vg, which is x Vg in this case. All right, so this is the formula that we are supposed to calculate, to use to calculate the volume of V wet. So this is going to be taken as our V wet. All right, so meaning to say, from that formula, we manipulated our formula, and so that we are going to write this as V wet in this case is equal to X by Vg, which is the volume for the dry steam in this case. Where are we going to have this Vg? At the same pressure. Remember, we are still at what? At 500 kilopascal. So we are going to obtain our Vg from there, which is going to correspond to what? So we are going to need Vg again across the same from our steam table. Remember, at 500, this is where we were at 500. So we need Vg, which is Vg is which column? This is the column for Vg here. Vg, this third part here across the third line here for Vg. We are going to need this value down there. So Vg across here at 500, this is our Vg there, which is 0.3747. So we are going to take this value for Vg, which is in cubic meters per second, under the 500. Remember, we are considering our pressure there at 500 kilopascal. So that's 0.3747, as we can see. So we are going to take this value into consideration. All right, so let's use our value here. All right, sorry, gonna take our value back here. All right, so we say the value of our Vg is going to be 0.3747, which is in cubic meters per what? Per kilogram. All right, so that's it. We're gonna just substitute here. We have got our V wet. So meaning to say our V wet is going to be X, which is our dryness fraction X there. Remember, it was 0.8. So it's going to be 0.8 times Vg, which is 0.3747. So we are going to obtain our answer in cubic meters per kg from there. So that's it. Our V wet is going to be given as, or we are going to obtain 0, so this was going to be 0.29976, which is gonna be approximately, this will change 10, which is gonna be 0.3. So we're going to end up with 0.3 cubic meters there. So this one was going to end up as 0.3 cubic meters per what? Per kilogram. If you are to calculate per kilogram now for that mass, we are obtaining the exact cubic meters if you multiply, but here we need it per kilogram. All right, so make sure that you understand how the question is given. Then the internal energy of wet steam in kilojoule per kg. Remember, we calculated the internal energy for superheated steam. All this part is just a mere change, or just a repetition that is happening. So from that formula, I'm not gonna go back to that formula sheet because we obtained this one before. We said our internal energy can be obtained from H minus PV. So this time we are considering for the wet steam. So meaning to say we are going to consider this as H wet. So this will be our H wet. This is the pressure at H wet, which means we are talking about the pressure of what? 500 at H wet in this case, which is 500. And also the volume in this case, we're talking about V wet in this case. So here we're going to refer to V wet so that we calculate the internal energy for the wet steam in this case. So this we can just write as U2, okay, P2, V2, and so on. So that's our U2 is gonna be H2, which is for the wet steam, we got 2,325.6. So that is the value that you're gonna use there. 2,325.6 minus P2, which is the pressure that we're working with under all these conditions. The pressure that we're working with was of what? 500 kilopascal. So we are going to be working with the same pressure of 500 times the volume for the wet steam, which is the volume there we got 0.3 after rounding off. So that is going to give us the internal energy, which is going to be 2,175,6 in kilojoule per kg. Make sure that you use your calculator properly on this one. All right, so considering at what? At the pressure P2 in this case. All right, so that is how we can have this. And the last part of our question, which is 3.7, was to calculate the change in internal energy in kilojoule. Take note what they are saying there, in kilojoules, in, meaning to say we are supposed to work, we are supposed to consider the mass when it is like this. All right, but the change in internal definitely, because we got an internal energy from the superheated, we also got the internal energy from what? From the wet steam. So these two, they give us the change in internal energy in this case. So meaning to say our change in internal energy is going to be the difference between these two values. All right, so that's our question 3.6. The change in internal energy is going to be given as U2 minus U1, which means from the wet steam and for that of the superheated steam. So that is U2 from our wet steam here. Remember what we got, that was 2,175,6. Take note, it's in kilojoule per kg, all right, minus the first one also in kilojoule per kg, because our answers there, they were in kilojoules per kg. So this is 2652,4. So meaning to say we are going to obtain our change in internal energy in kilojoule per kg. And this gave us a negative 47,476,8, which is in kilojoule per watt per kg. So the negative that we are simply seeing here, it means it's a loss that we are having, a loss in internal energy in this case, all right? That is a loss in internal energy. If we use U1 minus U2, it's a gain in internal energy from there. So here we are considering this as a loss of what? So we are considering a loss of 476,8 in kilojoule per watt per kg. It's a loss according to this. But the question is not, we are supposed to have this per kg. The question is, we are supposed to have this in kilojoules. Take note here, in kilojoules. All these, it was kilojoule per kg, cubic meter per kg, this one per kg. Now they need us in kilojoules. So how are you going to remove that? You are going to multiply by the mass in kgs. Remember, per simply means over. So you're going to multiply here. If you are given per, like this part, let me explain here. To remove this per kg, it simply means we've got a mass of, the energy of 476,8 kilojoules like this per kg, that is over 1 kg. So in order to remove this kg, you are going to multiply by the mass. That's why I was saying always on those calculations, you are not going to consider the mass, because the moment you multiply by the mass, the kg and the kg cancels, meaning to say you are left with the kilojoules now only. So that was going to give us 1,096,64 kilojoules in this case, which is a loss of 1,096,64 kilojoules in this case, which is being lost. All right, so that is how we answer this question. So meaning to say all these questions that we're working with, if they wanted us to calculate the answers here in kilojoules, you multiply by the mass. If they wanted us to calculate the volume in cubic meters only, we multiply by the mass, we get the volume direct in cubic meters. So these are the typical questions and how you are supposed to answer on STEAM. So like I said, it's a repetition check. August 2021 exam, you see that it's just a repetition. They do repeat. Even if you check on the boiler calculations there, we referred a lot of questions. You are going to see that it's a repetition that is happening. What you need is to know the concept, how to answer each and every question that you are given. Once you understand the concept of answering these questions, you are done, because mostly you are going to see repeated conditions as much. So it's best for you to revise as much question papers as you are preparing yourself for the exams that are ahead of time.